Alrighty, guys, we're going to continue reviewing functions today, and specifically, we're going to talk about the average rate of change. Now, if you remember when we talked about this in class, we related the words average rate of change with slope. Okay, so anytime they're looking for the average rate of change, we're going to look for the slope between whatever given points they ask us to find it for. Okay, now remember, slope is your change in your y value over your change in your x value, which also corresponds, since many of these will be in function notation, as a change in your f of x values over your change in your x values. So the first way we're going to look at average rate of change is as a table. Okay, right? A regular function table where the first column's x, second columns are function value, in this case h of x. And it asks us to find the average rate of change of the function over the interval 2 is less than or equal to x, which is less than or equal to 6. All right? So that interval right there is really important. It tells you the x values for which we are looking to find the average rate of change. So when we have an interval like this, right, those are the values that are going to go in your denominator being subtracted. So the 6 minus 2. Okay, so now what goes in my numerator? Well, remember, I want to look for the y value related to my 6. Okay, and in this case, it's a 3. And from that, I want to subtract the y value that's related to 2, which in this case is a 9. Okay, so we have filled our values in. Now all that's left is for us to calculate minus 6 over 4. And remember, anytime we do this average rate of change, we do want to express it in its most reduced form, or as a unit rate, which means the denominator is equal to 1. So in this case, in its most reduced form, we would get an average rate of change of 3 over 2, okay, or an average rate of change of negative 1.5, okay? So both of those would work for this. So this means that my function over time is decreasing, at least over this specific time period. So how else could they ask you about average rate of change? Well, they can ask you about average rate of change from a graph. So now, if they do ask you from a graph, and the graph is numbered by ones, okay, something that we could do instead of doing the slope formula and calculating is that we can count the boxes. Now, if you remember, this is another interval notation. Basically, what this says is that I'm looking for numbers from negative 3. The square bracket means it is including negative 3 and including negative 1. So from negative 3 to negative 1, okay? So basically, I'm looking at this point right here, and then this point right there. So what is the slope? Well, if I count boxes, 1, 2, 3, 4, 5, 6, that's going to be my y value, because I'm going up as a positive 6, over 1, 2, which is my x. Remember, when we're counting average rate of change, an easy way to do this with boxes is if we are counting the y value up or down, bring the negative with that. And then all you need to do to make sure you've done this correctly is count the boxes from left to right, as I did here. So this reduces down to an average rate of change of 3. What about the next one? Well, we're looking from x is equal to 0, which is this point right here, to x is equal to 2, which is that point right there. All right, we count the boxes. What's the change in my y? Well, we're going up, which is positive, 1, 2, 3, 4, 5, 6, over 2 x values, which is 3. So you should notice here that we have the same slope. We have the same average rate of change, okay? And that's because of a defining feature of this function. What kind of function is it? Well, it's linear. And for linear functions, no matter what 2 points you're looking at, you should always get the same average rate of change or the same slope, Okay, so anytime you have a linear function, that's going to be a defining feature is a constant average rate of change. Okay, but what happens when it's not linear? What happens when, in this case, we have a parabola? Well, we can still count the boxes in the same way, right? Here we're looking from x is equal to 1 to x is equal to 3. This point to that point. So although the line curves, all we're looking at is from point A to B. Okay, so we can count boxes 1, 2, 3, 4, which is in a negative direction, 4, and count boxes 1, 2 to get -2 as our slope, and that's going to be the average rate of change between those 2 points. It's like, well, how does it change on average from point A to point B? It's not asking specifically about what happens in between. Okay. So now what about the second one? From 2 to 5. So we're looking from here to here. Now we should be able to see one change immediately, right? From 1 to 3, we were going down. It had a negative slope. From 2 to 5, we're going up. 1, 2, 3 over 1, 2, 3. So you'll notice that the slope, or our average rate of change on a parabola, is not going to be constant between any 2 points, okay? And anything that's not linear, you'll see a similar thing. So it will be very important to pay attention to these ranges, especially for nonlinear functions, because it does not always reduce down to the same value. So now the average rate of change can also be asked if they give you just the equation itself. Okay, so we're given the function f of x is equal to -x squared plus 4x minus 1, and it's asking you to find the average rate of change from x equal to 1 to x equal to 3. Well, let's remember here, average rate of change is related to the slope, so we're looking for a change in y over change in x. Okay, now we're using our function notation here. But basically what we want to do is we want to see the difference between these two and their corresponding function values. So if I plug in 3, what do I get? I put that in the numerator. If I plug in 1, what do I get? I also put that in the numerator. So one thing that we have to do here is we have to evaluate f of 3, which in this case is minus, 3 squared plus 4 times 3 minus 1, and we get for that 2, okay, and I put that above the 3 because it's related to that value that I plug in, and then f of 1, which is 1 squared plus 4 times 1 minus 1, which in this case is also 2, all right? So as long as we have things correctly in line, all we have to do is continue our calculation. So that's 0 over 2, which reduces to 0, which means there's really no change from x equals to 1 to x equals to 3. Although you'll see changes in the graph between those 2 points. Okay, but all it really means is that we've returned back to the same value. All right. So now the last question that you could possibly see is talking about average rate of change in comparison. All right, it's just testing your knowledge of all 3 methods. How do we find it with an equation? How do we find it with a table? How do we find it with a graph? So we're going to do just that and then write them in order from greatest to least. Okay, so how do we find with a equation? Well, we are looking from 0 to 3. So what I want to do is I want to plug in 3 and plug in 0 to this function and subtract those values. So f of 3 is equal to 3 squared minus 2 times 3, and I believe that gives me the answer of 3. And f of 0 is equal to 0 squared minus 2 times 0 is 0. So 3 minus 0 over 3 minus, oh, no, I'm sorry, it's not 1. 0 gives me 3 over 3, which is 1. So my slope for g of x, oh, I made another mistake here. Sorry, I apologize. This should be a g of x just to match. The slope here is 1. Okay, so what about from the table? All right, so we're still looking from 3 and 0. So how do we do this? Well, x values go in my denominator, y values go in my numerator, and I get 7 minus 1 is 6 over 3 is equal to 2. So my average rate of change for the table is 2. And last but not least, on a graph, we want to count the boxes from x equal to 0 to x equal to 3. So I'm going up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. Oh, well, these two functions are actually equivalent. So if we're ordering from greatest to least, it really does not matter which one's going to go first. Right? F of x or h of x are equivalent. What really matters is if we're going from greatest to least is that g of x is last. So there's actually only one choice here that has g of x last, and that